In this video, we'll talk about the concept of enthalpy, which is denoted by a capital H. Okay, so enthalpy is the measure of the heat content of a system. Okay, so enthalpy is the heat content of a system. Okay, and most reactions that we study, they occur at a constant pressure. Okay, and if we're always interested in understanding systems that occur at a constant pressure, and we're not too interested, we're interested in the heat content, but we're not interested in the work. We're interested in the heat content, but not interested in the work, then enthalpy is kind of a good metric to use. Okay, so enthalpy is defined as H is equal to the internal energy E plus the pressure volume work. Okay, now as I mentioned, if we keep the pressure constant, because most systems occur at a constant pressure, and if you think about it, why does this happen? Because I mean, we live at 1 atmosphere pressure. Okay, so pretty much everything we see around us, all the reactions that are happening at constant pressure. So that is more something that we need to understand. Okay, so if you're interested in systems that actually happen at constant pressure, and we're not too interested in the work that the system does, but only in the heat that is exchanged, we can modify this expression and adapt it to work at constant pressure. Okay, so first we have to understand the change in enthalpy. Okay, so the change, because remember we have a system, and the system is exchanging with the surroundings. So there's going to be an initial state, a final state, and a lot of things are going to change in the process. So the change in enthalpy, denoted as delta H, is equal to change in internal energy E plus the change in the pressure volume work. Now to describe this change, we have to keep the pressure constant first and look at the change in volume, and then we have to keep the volume constant and look at the change in pressure. Okay, so this becomes delta E plus keep the pressure constant and then the change in volume, plus keep the volume constant and then the change in pressure. Okay, now since we're interested in constant pressure system, therefore notice carefully the delta P term, that becomes 0 because pressure is not changing. Therefore this entire term collapses, so that's vanished from the system. So therefore we can rewrite this as delta H is equal to delta E. We can put a little P out here as a subscript to denote that the change in internal energy is happening at constant pressure, plus P delta V. Okay. Now since we're doing everything at constant pressure, we can pull the first law out here, and we can put a little, a P out here. Delta P is equal to Q at constant pressure plus W, right? So that's the first law, the heat exchanged plus the work done, right? So we're going to replace this term out here. We're going to replace, this term with this. So that's going to become delta H is equal to QP plus W plus P delta V. So now what we can do is, we can take a look at the W and try to understand if the work is done, if that's a negative quantity or a positive quantity. And before we can understand that, we need to understand the context out here. Most chemical reactions that take place, they actually do work on the surroundings, okay, which means they lose energy as a result of that. Therefore, this work, because it's a loss, it's going to be a negative quantity. So what we'll do is we'll do QP minus W plus P delta V, okay? And then we replace that with a P delta V, because that's what work is equal to. And then notice carefully, we have a negative P delta V and a positive P delta V. Both of those go away. So therefore now we have delta H is equal to QP. And this is a definition for delta H. So the change in enthalpy is equal to the heat exchanged by the system at constant pressure. Now, delta H, if it's positive, then we're looking at an endothermic system or an endothermic reaction. If delta H is negative, we're looking at an exothermic reaction. Again, when delta H is negative, then the reaction is giving off heat to the surroundings, so it's losing, therefore negative. When delta H is positive, that means it's absorbing energy, okay? And negative is exothermic, positive is endothermic, okay? And then the last thing we want to talk about is when we talk about a chemical reaction, this delta H is written as delta H Rxn as a subscript. I'll write this a little better. Rxn as a subscript. This stands for heat of the reaction. Okay? Also known as enthalpy change of a reaction.